Hello, my name is Nathaniel Osgood. I'd like to welcome you to my channel. Today we're going to be recording two videos that are interdependent. In this first one, I'm going to be covering ways in which you can have several C modules that exhibit dependencies. We'll have module A and module B, and module A will depend on functions declared in module B and indeed on data items. And we'll see ways in which we can compile these for R so that we can load both as shared libraries into R in ways that captures these dependencies. The module A, once loaded, can call the functions in module B. The other video will be dealing with ways in which we can use GDB to debug code within those modules. So in order to show this means of compilation and means of loading modules into R, I'll go over and share my screen here. We're going to here have two modules, module A, this MMH, PMMC, etc., and module B, this Osgood-Liu particle filter 2014. And the key thing to realize is that module A depends upon functions declared in module B. So using a classic declaration style, we have an extern definition here. We can actually put extern if we want to, where we'll declare that this module A, depends on a function declared in the other module there. We'll see that within our code, we're actually calling it. And we'll go over, that was module A, we'll go over to module B, and we'll find that indeed that function is described here in module B. So module A is going to depend on module B for some functions, including that one we've just looked at. Turns out it's also going to depend on certain data items that are present in module B, such as this current maximum tier to log. Module A seeks these data items which are located in module B. So the first thing we're going to need to do is to compile both modules. And I've given the basic syntax here that you'd issue from the Linux or Mac command line. Presumably on Windows, it's somewhat the same. We do R space cmd space shlib space, and then the name of the module we want to compile. Similarly for this guy here. To make it particularly easy, I created a makefile which automates that process. It indicates what this code depends on, including a .h file as well as the .c file here, and then specifies how to compile that. Makes it particularly easy. And the key thing is that when we're going to do this, if we were to, for example, go do this from the command line here, what we would find is that and I'll just remove that the file which it produces here. And if we were to compile it in that way, what we'd find is that it produces a .o file as well as a shared library file that can be loaded into R. It's a similar thing for the other module, module A. So we've just, using this command here, compiled module B. We would do a similar thing for module A, and we would get out a set of .so files, which we're going to directly load into R. Okay, now how would we go about loading them into R? Well, I'll show you. First of all, you invoke R. I'm in the same folder where these are located for simplicity. Otherwise, you need to give paths. And I'll first show you how not to load them. So you might think naively that you could load them in a traditional way. So here I'm loading module B, and then I'm loading module A, which depends on it. And you might think that it should work fine and that it should resolve all the dependencies. And what you see is that it's quite unhappy. So specifically, when loading module A, when loading this module, which depended on excuse me, on the other module here, when loading this module, it reports not being able to find some of the elements. So functions that are used from there, and then this value here, it turns out that it can't load. And the reason is that those are not being loaded into a global symbol table, which this new loaded object can find. We need to load them into a symbol table. You'll notice it's saying there's an undefined symbol associated with this. In short, module A hasn't been able to find it in the compiled version of module B here and is unhappy. The reason it's actually not a problem with the .so, the issue is a problem with how these are loaded, and they're loaded not into a global symbol table, but into a local one. So I'm going to quit out of R here. That was how not to do it, and I'll go into R and show how you can do it properly. And the key thing is that you want to use this command, this option within the dyn.load command, which is local equals false. This option will load, indicates that we should load in the symbols from here module B into a global symbol table, which then this loaded set of symbols can load as well. And for good measure, I've declared those to be loaded into the global symbol table as well, in case there's later elements that depend on these. So, ladies and gentlemen, here we've had two modules, A and B. Module A depended on some things, data items as well as functions. In module B, we've seen how we can compile them using these sorts of commands from the command shell, from the standard command line. Those produce .so files. Going into R, we can load those .so files, but reflecting the dependencies between these modules, we have to say this, give this option local equal false to allow those symbols to be correctly resolved. So those are the essential things I wanted to cover. I wanted to thank you for joining us for that. And I'll be now recording a separate video on using GDB to debug the C code in each of the modules loaded. Thanks very much.